Hello everyone, my name is Naftali Ida. I manage the application engineering team for the PolyJet technology, and today we're going to go on a whirlwind journey of color and some recent improvements to our PolyJet capabilities, and we've made a small change that yields some amazing results. So let's get started. First off, we're going to do a quick color basics and terminology review so everyone can understand the topics we're going to talk about later on. So first off, we're going to talk about LAB. That's the color space that the human eye can see, and it contains approximately 1 million colors. Next, we've got a term called delta E, and that is a way to measure the difference between colors. So delta E is a single number that represents the distance between two colors. So if you've got two colors next to each other, you can just about tell the difference between them. That's 1 delta E, and it's based on a mathematical formula. So a color gamut is the entire range of colors available on a singular device or color space like a monitor or printer, and an ICC profile is a set of standardized data that describes the properties of a particular color space. So the computer monitor or a printer that can output color. So every device has its own ICC profile if it can process color. Finally, RGB and CMYK. So RGB is what is used on a computer, screen or monitor, and CMYK is the output typically from a printer. So RGB is based off light. So in order to render an image, you have 3 different colored pixels, red, green, and blue, and the intensity of the pixel is measured from 0 to 255. RGB 000 would be all the pixels being off, and then you'd have a black screen, and 255, 255, 255 would be all the pixels at full brightness, and then you would see a white color, versus CMYK, which is a subtractive process where the different colored inks subtract from the white of typically a substrate piece of paper underneath in the 2D world, and here the different drops of pigment are positioned relative to each other, next to each other, overlaying each other in different proportions to obtain the colors that you want. So basically in both cases, if you zoom in, you can see the makeup of the underlying colors. So let's move on to talk specifically about RGB and Adobe RGB, and that's really the main topic of today's session. So imagine the early days of the internet back in the 90s. Remember those big bulky CRT monitors? Well, displaying colors accurately across screens was a real headache. Every monitor seemed to have its own idea of what red or blue should look like. It was a confusing mess. That's where sRGB comes in. In 1996, HP and Microsoft said enough is enough. They created sRGB, a kind of universal language for color. It wasn't perfect, but it ensured a baseline standard for how colors would be displayed on most monitors. It was a game changer for the internet, making sure that, those funny cat pictures looked the same everywhere. But the story doesn't end there. Photographers, especially professional photographers, had a different problem. They were capturing all these beautiful, vibrant colors with their fancy cameras, but when they tried to print those photos, the colors looked dull and lifeless. Why? Because printers use a different system, CMYK that we just spoke about, cyan, magenta, yellow, and black, and that has a wider range of colors than most monitors of the day could display. So that's where Adobe RGB burst onto the scene in 1998, and that came from the boffins at Adobe, and this new color space aimed to bridge the gap between what cameras captured and what printers could produce. It offered a wider range of colors, particularly those lush green and blues that often got lost in translation. Now photographers could capture those stunning nature shots and see them come to life on high quality prints. So Now in this image, we've got the sort of colourful circle shape representing that LAB colour space. That's all the colours that the human eye can see. And within that space, we can see how the range of CMYK colours marked with a black line extends beyond the bounds of the sRGB shape. This means that when defining colours in sRGB, there are colours that you can technically print on your device, but have no way to access them. However, if we now add Adobe RGB, a color space that expands the printable range of colors significantly, here we can see the Adobe RGB form representation encompassing a larger spectrum of colors, expanding towards the more vibrant edges. This allows it to capture those captivating green and blues that the sRGB might miss. So imagine the emerald depths of a rainforest or the breathtaking turquoise of an exotic lagoon. So what would happen if I have a color, say that was positioned here, that has been selected in RGB? It's within my CMYK gamut, but outside of my sRGB gamut. So if I were to try printing this whilst using an sRGB profile, the color would be unobtainable and would be shifted to the nearest color that can be printed. However, if I've got the same color and I'm using the Adobe RGB profile, well, the color is within the expanded color space, and this will be printed as accurately as possible without shifting. Now you'll notice that there are still a small range of colors outside the Adobe RGB color space, but within the CMYK color space, these colors would be best reached by using, say, Pantone or CMYK input selections directly. Here's another view of the same information, but this time in 3D. On the left, we have the Stratasys 5-color profile versus the sRGB color space, and on the right, we have the Stratasys profile versus the Adobe RGB color space. So the Stratasys profile is kind of the colorful blob in the inside, and the Adobe or the RGB color spaces are represented by this sort of wider mesh. In both cases, you can see whilst the Stratasys gamut is smaller than both color spaces in total volume, there are areas of that CMYK color space that extend beyond the bounds of the RGB color space. So these are colors that you can technically print, but have no way to access using the RGB selection tools. So let's take a look at the process workflow just to round off this section. And here we're going to talk about how color management works and why it can often be difficult to predict what the printed output will be if you aren't using, say, printed reference parts and only relying on RGB color assignments. It's important to note that this process happens regardless of whether you're working with sRGB or Adobe RGB. So let's say you have this beautiful image here and you wish to import it into GrabCAD Print. You want to see in GrabCAD not the model how you designed it, but to be able to appreciate how it will print. And in order to do this, a few things happened kind of in the background without you having to do anything. First, the colors have to be converted into CMYK for printing. So to do this, they aren't converted directly, but they are converted via the LAB space. Now remember, that's the color model that represents all the colors the human eye can see. And then now we can move from there into CMYK. So here in CMYK, well, we're good to send them off to print. But if you want to understand maybe before how you send to print how the colors are going to look, you have to go back to the RGB color space to view that on your monitor. And to do that, we go through the LAB color space, but this time with the CMYK data as a starting point. So we're going to have sort of a change in what we're going to get. And then we'll be able to see that representation back again in RGB on my rendered monitor. So here we can see the key stages across the process, and that each stage has a slightly different output. So basically there's a lot of nuance lost in translation that happens as the colors are converted from one color space to another to enable printing and also to enable you to view or proof that print. So the best way to truly understand what you're going to get from an RGB assignment, be it single color or via texture, is to print a sample. And that will enable you to understand how the colors will be converted from screen and represented in print. Now, we understand probably more than you ever wanted to know about Adobe RGB, and let's take a look at how to implement this in GrabCAD Print. Well, it couldn't be simpler. Here we have a model imported into GrabCAD Print, and we're simply going to navigate to the tray settings, and from there we'll select the advanced tools, and from the input color profile drop-down, we'll change it from the default sRGB to Adobe RGB. And that's it. We're ready to send the part to print. And let's look at some printed models so you can see what the difference is going to be. Here we can see on each row of these parts a different single color applied using the color picker within GrabCAD Print. The left is sRGB and the right is Adobe RGB. And in the table you can see the actual colors that we've selected. So you can see that these colors are highly saturated. They're above sort of 200 in the RGB space, and we can see a real change in the output of the color. So another example here, we've got a photograph of the image that we used earlier. Both of these are printed on the left in sRGB, on the right in Adobe RGB. And here I've highlighted some of the areas to look at for some noticeable differences in color. We've got some improvements in reds. We've got some beautiful sky blues. We've got these healthy, lush greens. We've got this rich sea blues, and we've got some intense forest greens as well. And here's a dynamic comparison between the two as well. And we can really see that difference in vibrance and vividness across the image in Adobe RGB compared to sRGB. So in our final printed example, I wanted to highlight another area where we can see an improvement when using Adobe RGB, and that is when printing skin tone colors. In this case, we purchased a head scan from the 3D scan store, and here you can see on the left the on-screen render reference and the sRGB print. Unfortunately, this printed model with the sRGB, it lacks life and seems a bit pale. However, when printed in Adobe RGB input profile, we can see there's more warmth and realism in the skin tone colors. So let's summarize. If we take a look at some of the numbers, the Adobe RGB gamut is over 45% larger than the sRGB. And if you use the Adobe RGB input profile, you can access an additional approximately 100,000 delta E colors compared to using the RGB workflow. So when the user specifies an RGB color, they're making a reference to a color as seen on some display device. The user must then tell GrabCAD Print something about that display device. Was it an old TV set of the 50s, or was it a modern OLED monitor? Having failed to do so, GrabCAD Print until today assumed that the color seen was dull and so printed a dull color. Now, by telling GrabCAD Print that the color was seen on a good monitor, Stratasys will try and print a more vivid color to better emulate that selection. To review and some closing remarks. So it's a color gamut, Adobe RGB, that can capture a wider range of colors and those are more similar to those used in professional printing rather than, say, those that you can represent on a monitor. The target is really for customers who are interested in more saturated colors. So that could be, say, figurines and collectibles or entertainment markets, and that would be, say, packaging as well. It's available and it's easy to apply. It's available for anyone that uses GrabCAD Print. You don't need Pro, and it was made available in the most recent launch, which was 1.91 version of GrabCAD. Now, call to action is go off and print some of these models. I've got a sample tray you can access from the QR code here, and print it once using the sRGB profile and then a second time using the Adobe RGB, and you see the difference for yourself. Please provide us with feedback, what's improved, what maybe needs additional work, and we'll come to that in a later update. Thank you very much for your time today. and happy printing.